Hi everyone, I'm gonna be doing question 4 of week 4A homework. Question 6 of week 4A homework. In this question, we are given an electron being shot straight up into the air in New England, and we want to figure out how much it's accelerating because of Earth's magnetic field. So first we could look at this quick sketch I made to set things up. So here's the ground, the horizontal line I made here, and here's our electron. So the problem says it's shot vertically straight up. So I drew this arrow vertically to represent v, which is velocity, and then it also says that Earth's magnetic field is horizontal. So I drew this line here called B, pointing sideways because one is straight up and one is flat sideways. They will make a perfect 90-degree angle, which is why I drew this box here, and it will be very important in a second. So before we do any math, we will talk about our variables first. So we know what everything means. So first we have B, which I wrote here. And so B is the magnetic field strength, which is basically telling us how strong the magnetic field is. And so its SI unit is in the Tesla. Next, we have velocity, which tells us how fast the electron is moving, and its SI unit is in meters per second. Um, Theta is the angle between the movement and the field, which is, as we know, 90 degrees. And then Q, as I wrote here, is the electric charge of the electron, which is measured in coulombs. And M is the mass of the electron, which is measured in kilograms. F of B is the magnetic force, which is like the actual push the electrons feel, which is measured in newtons. And then finally, A is the acceleration, which is like how fast the electron speed is changing. And that is measured in meters per second squared. So to actually solve this question, we need to first do two main steps to figure this out. So first we need to find out how much force is hitting the electron. And so the equation for that for magnetic force is F of B equals the absolute value. And I wrote it here. F of B is equal to the absolute value of Q times V times B times sine of theta. And so if we look up the standard charge of an electron, that would be 1.602 times 10 to the negative 16th coulombs. And when we plug that in, then multiply by the speed given in the problem, which is 1.8 times 6, 10 to the 6, well, meters per second. And then we multiply by the magnetic field, which is 2.2 times 10 to the 5th Teslas. And since, as we know, the angle is 90 degrees, we will do sine of 90, which is basically just 1. And so when you throw all that into a calculator, you would get a magnetic force of about 6.344 times 10 to the negative 18th newtons. And so now for the second step, because we found out that the force, we can now do the second step, which we need to turn that force into acceleration. So we could use Newton's second law for this, which is just force is equal to mass times acceleration. And if we rearrange that, like how I did here, to solve for acceleration, it becomes acceleration equals force divided by mass. So we just found the force, which will be on the top here, as I wrote. And so we put that on the top. And for the mass, we will just look up the standard mass of an electron, which is a tiny number of 9.109 times 10 to the negative 31 kilograms. And so when you divide those two together, the numbers will cancel each other out and will give us a very like high acceleration of 6.96 times 10 to the 12 meters per second squared. And that's our final answer. And so the problem told us to ignore gravity, which kind of makes sense because this magnetic field is like super huge compared to normal gravity anyways. So thank you for watching.